Hi, David Cann here with another question from your Hayes and Harris Math SL textbook. This is Chapter 3b, Question 1, Parts A, G, and K. So for Part C, it says simplify this expression and then use a calculator to check your answer. This expression, we have a base and an index, and it tells us take -1 14 times, multiply them all together. So -1 to the power of 14 is -1 times -1 times -1 times -1 times -1. We'll just keep doing this. All together, we'll do it 14 times. Okay, well, we could do all this multiplication. That's possible. But let's take a look at the pattern. If we take 1 times 1, or sorry, -1 times -1, that gives us +1. But if I take -1 times -1 times -1, well, that's -1 times -1 is +1. +1 times -1 is -1. Let's keep going. Let's take the first 4 now. That's -1 times another -1. That's +1. We'll do one more. +1 times -1 is -1. So we see that as we keep multiplying by -1, the result keeps alternating positive, negative, positive, negative. If I have an even number of negative numbers, I get a positive number. If I have an odd number of negative numbers, I get a negative number. So odd number results in a negative number. An even number of negative ones results in a positive number. And this isn't going to be unique to -1. This is going to be true for any negative base. A negative base to an even index results in a positive answer, and a negative base to an odd index results in a negative answer. Now, for -1, the unique fact is that no matter how many times I raise 1, no matter what index I raise -1 to, I always get 1 or -1. It doesn't grow in size. So, what that means is that -1 to the power of 14 is going to be either positive or -1. Because the index is even, it's going to be +1. Part G is going to work out very similarly. Part G, I have -1 to the power of 8. Now this can be a little bit hard to interpret, so let's take a look and let's remember BOMDIS. Brackets have to be done before this multiplication. So I have to take care of this area before I deal with this negative. So that's negative, so it's this negative sign right here. And then I can treat this -1 to the power of 8 using this same rule. -1 to any power is going to give me either +1 or -1, but the index is even, so again it's going to be positive. So all of this results in just 1. But I had to evaluate this before I can evaluate the negative sign out front because of order of operations. So the negative sign stays out front. So -1 to the power of 8 is equal to -1. Finally, we'll do the same thing for -5 to the power of 4. We have -5 to the power of 4. This rule still applies. Any negative base to an index like this, if the index is even, the result is positive. If the index is odd, the result is negative. And this is yet again another even index. So I know the result is going to be positive. What it is it's going to be 5 times 5 times 5 times 5. And we already found out from the previous question that that is 600. All the negative signs are going to cancel out because we have an even index. Next, the question asks us to check these answers on the calculator. So let's pull up the calculator. And let's check -1. And it's important that we use this negative sign, not subtraction. Subtraction is an operator. This just changes the sign of the number. So we want -1 not subtract 1, to the power of 14. And I said that should be positive 1. Let's see if I was right. Whew. Thank goodness. Okay, so negative 1 to the power of 14, because we have an even index, we get positive 1. Next, let's try negative 1 to the power of 8. I predicted that this should be negative 1. Okay, it is. So negative 1 to the power of 8 results in a positive 1, but I have another negative sign out front that still gets applied. Remember, that's what we said out here. This results in positive 1, but we have a negative sign still out front. Lastly, we have negative 5 to the power of 4. So negative 5 to the power of 4. And we get 625. Ooh, whoops. Looks like I didn't multiply my powers of 5 correctly. Yeah, 625 would be the correct answer. At least I got the power correct.